Comenzamos con la siguiente plática. Un aplauso, por favor.
Hi, everybody. I apologize for our inability to speak Spanish here. That's very sad. So we're going to present in English. The topic is converting C code to JavaScript. How many of you heard about Emscripten? I know this guy, Emscripten, the framework Emscripten. So the framework is amazing. I was Googling the other day, compiling JavaScript to compiling C to JavaScript. This is the topic, right? And this sounds kind of crazy to me. Like, how can you convert the C code to a JavaScript? But I Googled it anyway, and I come across this wonderful framework called Emscripten. And so what Emscripten basically is a tool that allows you to convert any C code to JavaScript code that you can run on the web or on your backend server with Node.js. And that all works with very fast and without any plugins, which is quite amazing. So the way it works, it actually compiles your your C code to Awesome.js. And Awesome.js is a subset of the JavaScript. It's a highly optimized, basically highly optimized JavaScript code. The way it's optimized, it basically has like a static types and static arrays. So what it allows you to do, it allows you to bring a library, for example, a very performant library, such as like OpenCV for image processing, or like any game written in C++ to your front end and run it in the browser. There is famous examples that was compiled with C with Emscripten. This is all the examples of originally written in C. Huge library, like probably thousands and million lines of code. For example, famous library like OpenCV, some of might know, used for image processing, self-driving cars, any kind of like image manipulation. FFmpeg, I personally like it. I work a lot of with video processing and media. And FFmpeg used for video encoding or any sort of image processing as well. SQLite, also very, very popular library used by tons of projects, including Skype, I think, used with the app. That was compiled to JavaScript, and so you can run this library in your browser. Tazerac is another example. It's basically converting image text to images. Like if you have like a scan of a document, you can convert it to a text, done by Google. You can see more example on the actual website of Emscripten. I posted the link right here. So I want to just show you what it is, like from like a first kind of hands. And for this, I'll just show you a little demo of compiling this little piece of C code, and I'm doing right now doing it live. Hopefully it take 5 minutes or so. Sneha can help me with the mic. This would be great. So right now I have this directory here. I'm located the user dep. Can you guys let me make it bigger? Okay. So I have this directory with the following content. I have a build script. I have a main CPP and main.js. Let me remove main CPP and main.js from here, because this is what we're going to create. And I'm going to, now we have just the build script. And so now I'm going to create a main CPP file. So CPP extension, for those who don't know, it's a C++ extension. And you're going to write some C code inside of this file. And then you're going to compile this to a main.js, which will run with Node. So I'm using the VS Code here. Just my text editor. You also make it bigger. Okay, it's a good size. So let me just, I'm going to copy paste from this slide, and I'm going to explain line by line for you. So this is a very, very simple C++ program. It can contain one function called getGreeting, and the function type is a constant character pointer, and it's basically return a single string, said hello world in C++ as this message. And we also implemented our main function because C required this main function to be there. The one important note that you can might see this kind of weird extern C, and it's everything wrapped inside of this extern C. This is to prevent a compiler from mangling your name into a weird format. So because after compiling, we still want to access our function through JavaScript with the same name. You'll see it in a second. So basically the idea, we want to run this getGreeting function from our JavaScript code. Let's do that. So inside of the build script that I just showed you, there is a following command. So m++ is an mscripton executable. And the first argument that we have here is just optimization argument because we want our JS file be small. The second one, exported function, you can actually see that this getGreeting name, I'm specifying explicitly which function I want to get. And you can see this underscore because this is how C mangled the name. They append the underscore when it's compiled. There's a second part of this, couple exported runtime method, this CWrap and CCall. That's for just some scripting as the documentation. You will see in a minute how we're going to use these things. And the most important part, of course, we're providing our main CPP file as an input, and our output is going to be main.js. So let's see how the magic will happen. So because this is really mind-blowing for people who work with C and like JavaScript, and just see like how C code transform in JavaScript, just mind-boggling. And this is a trivial example, but you can see it with the giant project being converted to JavaScript. So this is what I have now. I have two files, build sh and main CPP. And so this build sh contains the command that I just showed you. Here it is. And so what I'm going to do, I'm going to just run this build script. Everything went fine. And now I list the file again. You can see main.js get generated over there. And just for the speed's sake, I will show you how to use it with a Node. Node is the runtime JavaScript interpreter. It's been created not that long time ago, and it's used to run JavaScript on the backend. So this is a Node interpreter. Can you hold the mic, please? So I'm going to first import my main.js module. And for that, I'm going to use JavaScript require command and say main.js. So now if I execute my main, you can see that this is an mscripton module object. So you might think that I can run my method from this object, my function, getGreeting, but it's not that easy. I need to use the CWrap to wrap it around. So this is what I'm going to do. I'm going to CWrap. And I'm going to say getGreeting, my function name. And I'm specifying the return type, which is a string, which is a JavaScript type. Because JavaScript only have 3 types. It's a string, numbers, and something else, a Boolean. So this return me a function. Let's throw this function to a variable, actually, to getGreeting.
What?
I'll let. So, and now I just go into print getGreeting. You see it said it's a function, but I need to execute it, of course. Ta-da. So this is in JavaScript from C++. Pretty cool. And just to kind of prove the point, this whole thing can be run on the front end, in your browser, in Chrome or any other browser that runs JavaScript. So if you write, this is the browser code, right? You might recognize some HTML here in the script. So what I'm doing, I'm saying like getGreeting doing this CRAP, you just see, I stored the result in this get greeting, and then I just assigning it to a message in H1. And so the result of this looks something like this. Let me show you. I have it in this Emscripten demo, another one. I have this index.html. It's the exact same thing that I show you. I just built it in a file. So you can see a hello world from here. And this file contains, I can show you as well, it contains this following code. Exactly what you saw, just script, and inner HTML, and using this main.js file as included right here. So we were excited about that, and we have like a real project that we want to build, kind of completely unrelated, but we have a problem that we couldn't solve. And Emscript actually come in handy, the project called Vertex Cache. And Sneha are going to talk about this project a little bit and show you some cool stuff too.
Hey everyone. So Vertex Cache, for example, we were basically attacking this problem of how we want to take an animation from Houdini, which I don't know if anyone's heard of it, but it's a 3D modeling and simulation software. And we want to take this animation and port it to the web so that we can view it interactively. So, for example, this is it's a simulation that was created in Houdini. So it's just like some squid coming down, and but the problem is that it's not interactive. If you wanted to show this to people, you have to like render this and show it as a video, but we want to have it interactively on the web. So what you have to do is find out a way to like transfer this animation to the web. And what you can do is basically store each point position into this image. So this imagery contains like all of the data of that animation that you just saw in that last video. So it's basically the width. Every point, pixel point on this picture refers to a vertex point on that previous mesh. And if you go down this, it's the overtime element. So it's like the value for how this position point is going to change over time. So we've stored it, it's all in this image, but now we have to be able to read this on the web. But the problem is that browsers only support 8-bit image format, which means that there's not enough precision when we're trying to read this image on the web. So, and we need something just like with higher precision, because if you use 8-bit, then you get these animations that are kind of like fuzzy, because each like position on the mesh is not exactly where it's supposed to be. So there is an image format though called EXR, and this is a high precision floating point that's just widely used in visual effects. But the problem is that the EXR loaders have only been built in C++, but that's when Emscripten comes in handy. So we found a library on GitHub called TinyEXR, and it's basically like a lightweight C++ EXR loader. So we compiled this with Emscripten so that we can use it in JavaScript and basically show the exact same squid that you saw in Houdini, but this is running on the browser.
And this is interactive.
And this is interactive. And this is using Three.js.
Creepy. So if you want to see this example and some other project, you can go on codercat.club, where it's our personal website. We post all the projects, and the suite is there. You can just kind of play around, and you can also see the code, how it's built. It's all on the GitHub. You can like examine it yourself and see how it's done as well. codercat.club. Thank you.
Yes.
Oh, question.
Forgot a question.
I do have a question because I can imagine the case. Are you guys familiar with Webpack?
Yeah, I'm familiar with Webpack. Yeah.
Okay, so I'm imagining I could write in my code something like require main.cpp or whatever.cpp on my code, assign it to a variable, and then just straight up use it with a Webpack parser, plugin, loader, yeah, a Webpack loader.
Like it's a compiled for you.
Right, exactly, because it will recognize the extension. It will know which loader to run. I can imagine it running through Mscript.
It might be possible to build a build system. It might be possible to build a build system like a Webpack, right, for this. Because as you saw, I'm doing it manually, right, specifying this command line arguments. And also, like, I'm using this weird CWrap. So if you actually want to have like a more pleasant JavaScript experience after you compile it, you need to write a little bit of more C++ code, and it's called mscript and mbind. So you basically write a class in C++, and then this class gets automatically exported as a JavaScript class. And you have this very nice interface that you can use, that almost indistinguishable from like a JavaScript interface. You don't have to go CWrap. And it's probably possible to build a system that actually prettify it for you like a Webpack, right, and do it automatically.
Has this technology been used to run games in the browser? Like games that were developed in C?
Yeah. So yeah, if you go on the website of Mscripten, there's this huge, big project. I myself work in the visual effects industry and games. And so we use two big game engines, right? One of them called Unity. You might have heard about it. It's very famous. So in Unity, when you build for a web, there's an option to build for a web, right? That's what exactly going to happen. All your code that you run in the C#, which C# can be also compiled with Mscript and not only C++. All this code gets compiled to JavaScript. And there are examples on very performant games online done with this technology. The other example is, what's the game engine is? Unreal Engine. Unreal Engine is one of the top cutting-edge game dev engines now.
There was a project in Google around 10 years ago called GWT.
Which one?
GWT.
GWT.
Which was a transpiler from Java to JavaScript.
Oh, I know that.
Yeah, basically, it was because the Google engineers were very good programming in Java, and they needed to bring like the Java world to the browser.
Yeah.
So I think like the very first version, well, some versions of Gmail were written in Java, then transpiled to JavaScript.
Nice.
I heard about it. I heard that from the development standpoint, it was a little difficult to work with.
Yeah. Well, my question is about eventually the JavaScript world catch up with the conventions of the combined languages, and it has been evolved ever since. Do you think that something similar will happen to a project like this one, in which I haven't heard of GWT for 4 years now, and it's because the JavaScript community is growing bigger and bigger.
Have you ever heard about Mscripten?
I haven't heard. Yeah. It's amazing. I mean, it's it's amazing. But eventually, with 3JS and all the technologies coming from down the browser, like WebGL and all that kind of stuff, do you think that eventually it will catch up and like projects like this will be like an anecdote instead of
I mean, my personal opinion, I see that the world of JavaScript more into more performant JavaScript in the browser. And there are projects like my friend Ravi mentioned today, I didn't know, they're like his friend working on compiling Windows, C++, or C# tools to Chrome OS, and the Chrome OS is JavaScript based, right? And I see a lot of people working on like Asm.js, because the core technology here is like Asm.js as well. It's the subset of JavaScript, very high performant. And what Sneha showed you, she worked with a library called 3JS. It's basically a wrapper around WebGL. So it's this computer graphics running in your browser. And I think people are very excited to see that, because like you can share your content, you can share your games, visualization, like video or any kind of stuff in the browser with the same like performance. And for me personally, and scripting also, it's like utility tools, right? We have this real problem that we couldn't solve with the project like Vertex Cache, and it's like, oh, this is handy. Like, you know, it's just a tool in your toolbox at the end of the day.